Okay, so now let's look at a center of mass problem. And this is a little bit different than some of the ones that you've seen in your book already. So if you want to get some practice working problems like this, you should really look in the Halliday Resnick Walker book that's on reserve in the library. It has a lot of problems that's calculating the center of mass of things that where the center of mass isn't necessarily, you have a collection of point particles. For example, this problem here. So what it says is, let's say we have 3 rods and they all have length L. Okay, and let's also say that they all have the same mass, and the mass of the, well, actually no, let's say they have different masses. So the mass of the one on the left is m. The mass on the one on the right is also m. But let's say the one on top has a mass of 3m. Okay, and then we'll say that the bottom left-hand corner is the origin, which is just another way of saying that that's the point 0, 0. Okay, and so the question is going to be, find the center of mass of this system. Okay, so how would we do that? So think about that for a second. Maybe even pause the video and think about how you would do this. And then unpause it and start watching again. Okay, so here's what we want to do. If you remember, back in the videos, we said that if you have a collection of particles, you can find the center of mass of each collection of particles and then find the center of mass of those. So what we do is we look at each rod individually. So first we look at the rod on the left. And again, we said that these are rods of uniform density, which means the center of mass is just going to be halfway up. So that's going to be the point x is equal to 0, y is equal to L over 2. Now we look at the top mass, and again, its center of mass is going to be right in the middle. And its x now is going to be, we go over L over 2. But now we go up a distance L. And then the same thing for the one on the right. Its center of mass is going to be in the middle. Now we go over L, and we go up L over 2. So now we really have 3 points now, and we just need to find the center of mass of these 3. Okay, so we should be able to do that, with no problem. So we know, so now we use our formula for the center of mass and say it's the mass of the left rod, m, times its center of mass, plus the mass on the right times its center of mass, plus the mass of the one on top times its center of mass. And then we divide all of them by the total mass. Okay, and so notice when I did this that each of these center of mass components is a vector, right? This is only true for the vectors. You're not finding the magnitude of the vector. It's the components of the vector. That's what this formula holds for. So when we work this out, so we see that the m's all cancel out. We can pull out an overall factor of L. So we just have 0 plus L over 2. So we have 3L over 2 for the top. We have L over 2 plus L over 2 plus L. And so, I'm sorry, this is 3L over 2 plus L. So this should be 5L over 2. And again, we have a 3L plus L over 2 plus L over 2 is 4L, all multiplied by this factor of 5. So we see that our center of mass is at, oops, I pulled the L out here. I can't do both. Okay, so we'll have a 1 there. So If we pull the 5 in, we see that this is just L over 2 in the x direction, 5 over 4L in the y direction. Okay, so I would have noticed if I hadn't noticed that I had an extra L out front, my units wouldn't have checked out, right? Because I would have had because L has units of length, and I would have had something that's like length squared. But instead, so I just have both of the x and y components are just the only unit in its length, so the units check. Okay, now let's see if it makes sense. Well, we notice that there's a certain symmetry that goes right down the middle. So we automatically know that the x center of mass is going to be along this line, because the rods on both sides are identical. And so we would expect the x component to be L over 2. And so sure enough it is. Okay, well, what about the y component? Well, we know halfway up is also L over 2. And so we have another rod on top, and this rod has the heaviest mass. So we would expect the center of mass to be somewhere greater than L over 2. And that's what we see, right? We see 4/5 L, and that's greater than L over 2. So if we look at our sanity check, our answer makes sense too. And so this is the answer. So this is how we find the center of mass for something like this. But it could even be with more complicated things. We can make this problem as difficult as we want, put as many different rods and objects in whatever configuration we want, and we just find the center of mass of each one, and then we find the center of mass of their center of mass. And so that's all there really is to a problem like this.